For the next operation, we're going to create a surface high-speed area roughing or rest material strategy toolpath. A surface high-speed area roughing with rest material strategy toolpath is designed to calculate the cutting passes on only the stock left over from one or more previous roughing operations, instead of the entire drive surface. In our case, we will use the stock model as a previous operation. Come up to the top and select Xform and go to Project. From here, we need to select the entities we want to project. Select this line here, followed by this line, and this line here. We should have 3 pieces of geometry selected and hit Enter on our keyboard. When this is done, we want to project these 3 geometry lines up 1 inch. And we want to make sure that copy is selected. Come down here and select Use New Attributes and select OK. Once this is done, we will clear our colors. Come down to the bottom and select Level. Under Level, we are going to turn off Level 1 and hit OK. If need be, select Fit. Come up to the top and select Toolpaths. From here, hover over Surface High Speed and select Area Rough. Mastercam will ask us to insert a new NC name. Just leave yours as default -tutorial 3. Select OK. We now need to select drive surfaces. Come over to the right hand side and select QM Solids. When this is done, hit Enter on your keyboard. From here, come to the left hand side and select Containment. We will use the geometry that we moved up as a containment boundary. Select this outer circle, followed by this circle here. Select OK when done. Select OK again. As you can see, the toolpath page will load up. On the right hand side, we can adjust any of the drive, check, or containment boundary parameters without going back and chaining the stock again. We want to make sure that the containment boundary is from outside. Once this is done, come over to the left hand side and select Tool. Select Library Tool and Filter. From here, we will make sure that we select the bull end mill with a tool diameter equal to 0.5. Once we have this, select OK. Grab tool number 345 here, and then proceed on by selecting OK. The tool will appear in your own personal tool library. Once this is done, come over to the side here and type in the comment. Rough out the part. Once you have your comment in, you can also change any of these parameters up here, such as the feed rate, plunge rate, spindle speed, etc. Come up to the side here and select Cut Parameters. In Cut Parameters, make sure that these values align with that of your training tutorial. If you need to, change the values accordingly. We need to make the minimum 0.12375, and the maximum here we need to make 0.225. Once this is done, come over to the left hand side and select Rest Material. In Rest Material, we need to turn it on. From there, we need to use one other operation and make sure that our stock model is checkmarked. Come down to Adjustments to Remaining Stock and make sure you select Use Remaining Stock as Computed. Once you have this, come over to the left hand side and select Transitions. In Transitions, we need to make sure that Entry Helix is turned on and it gives us a radius of 0.25. Hit Enter on your keyboard when this is done. Come over to the left hand side and select Steep Shallow. In Steep Shallow, we are going to use Z depths and give the minimum depth 0 and the maximum depth -1 and hit Enter. The Detect Limits automatically populates the fields with minimum and maximum depths based on the selected drive surfaces, if I were to select this button here. Come over to the left hand side and select Linking Parameters. In Linking Parameters, we need to make sure that our clearance plane is set to 2 and that it's absolute. We also need to make sure that this changes to Minimum Vertical Retract here. Turn on Output Feed Move and give this a value of 500. Hit Enter. From here, we need to go down to Part Clearance and also change this value to 0.25 and hit Enter on your keyboard. Once this is done, ensure that all the values align to that of your training tutorial before proceeding. Select OK when done. Once your toolpath is created, it should look something like this. Before we go to backplot and verify, come up to the backplot verify options. Come down here to stock model and turn it on. Select OK when done. Now we will go to our backplot. Once our backplot loads, make sure that you can see the part. Go to View, select Fit and Isometric. Come up to backplot itself and make sure all operations is turned on, follow is turned on, leads is turned on, and I'm going to turn off enable vectors. When this is done, go back to Home. In Home, make sure you select Workpiece and that workpiece is turned on. Come up to the top, select View, select Isometric and Fit to your screen so you can see. Select the play button. If that toolpath moved too quickly, you can always adjust the speed down below. Come back to the home page and select Verify. In Verify, we want to make sure that Workpiece is turned off. We also want to make sure that Tool is turned on, Stock is turned on, Initial Stock is turned off, Wireframe is turned on, Axis is turned on, Fixtures is turned on. Once we have all this invisibility turned on, make sure Color Loop is on and select the play button. Your part should look like this when it's all said and done. Come up to the top and select Close.